hi, namaste. My name is Jeevan Jyoti Biswar and you are watching Do and Code YouTube channel. Today's topic is solid principles. Like we have to learn about the 5 principles, which is going to be help us to design a object-oriented design. In this topic, I am also covering some real-world examples, which is going to be convenience for all of you. Like you can just understand the topic, not only the principles, also how you can implement those things in your project, or if you are a working professional you can also improve your code base like this. Okay, let me start with the design principles. Okay, first one, what is solid? Solid is set of 5 design principles in object oriented programming, helps create understandable, flexible and maintainable code. That is just nothing but a simple definition for solid principle. It is help to design a object oriented designing pattern, and also going to help help us to create a understandable design. Like that design should be understandable and it should be flexible, means it can be understood by anyone. If you have coded this thing, if some other developer is going to see your code base, then he or she can also understand what is the design there, what is the kind of principle you are using. Then maintainable code, by using this, it will be by a long run it will be help us to maintain our code base. That is the major thing or major important for the solid principle. The acronym is like S for single responsibility principle, O for open close principle, L for Liskov substitution principle, I for interface segregation principle, and D for dependency inversion principle. Okay, these are the 5 principles and these are the acronyms for SOLID. Okay, let go to each every single acronym. Like S, it stands for single responsibility principle. Let me go to that one. Like it is a single definition, like a class would have only one reason to change. Like that, there should something have some single reason that is going to be the major reason which is going to the change the class. Otherwise we cannot toss that class direct, we cannot toss that class, or we cannot change that, modify the class directly. We can go to the code. Like it is a bad example for that SRP. Like there is a class invoice and having 3 methods, like void calculator total, then print invoices and save to database. Okay, the class invoice is doing 3 operations: calculation, then printing, then that is saving this data into a database. Rather than this, what we can do, we can do one thing. Like as per the definition, you can see here, a class would have only reason to change, or a class would have only one responsibility. It is the definition for solid principle. As the name said, single responsibility. The class would have only one responsibility. Here the good code will be, we have to create a class invoice having a calculation method. It is going to calculate total. Then having one printer, invoice printer class, which is going to be print our whatever the invoices. And having another class which is a repository, invoice repository, it is going to save our data into our database. Okay, this is the single class, means SRP, single responsibility principle. Then single class should have single responsibility, or you can, another definition is like a class should have only one reason to change. Okay, this is the simple definition for this one. Let me go to the second, open and close principle. Open close principle said, like software entities should be open for extension but closed for modification. Means we can extend that particular entity but we cannot modify the code for that entity. Means here whatever the good code and bad code, it is going to be moreover clarifying the definition. Okay, at OCP or open close principle said, as per the bad example, I am creating a class as notification. Here you can see I have a method called send, void send. It is going to be send something. Okay, I don't know what is the kind of thing it will be going to send. As you can see, here is a parameter called as type. If I am checking if the type is email, then I am going to send a email. If my type is SMS, then that time I am going to send a SMS. But just think this code, this kind of code for a OCP. as per the OCP definition, it should be open close principle. Open close principle, as you can see, like open for in software, open for the extension, not for the modification. You can see as per the definition here, is it is going to be satisfied the definition? No. You can see the class notification, it is depending upon the always modification for the send method. If I want to implement something like I want to implement some other kind of messaging system, then I have to implement here only. Rather than this, what we can do, we can do one thing here. Like as for the OCP says, we have to create an interface called as notification. It is having one single method, single send, means void send. It is always going to be send something. Okay, if I am using a email notification, that time I have to create a class email notification and implement that notification interface, and then I have to modify my code for the void, or sorry, for the send method which is present inside our interface. I have to implement that abstract method into my implemented class. Similarly, for the SMS notification, I have to do the same. Whatever the thing I have to write the logic, I can write here. Let me go to that third principle, Liskov substitution principle. As per the definition, say, you can see here, subtypes must be substitute for their base types. Means subtypes always should be a substitution for a base type. You can see here the bad code. Okay, LSP, it said, like bad example is like, there is a class bar, there is a method called as fly. Okay, now imagine I have a class called as orchid. You have known, like orchid cannot fly, they always run. Okay, for that particular orchid class, if I am extending the bar as a parent class, then what will be happen here? You can see that I have to throw some exception because orchid cannot fly. For me, it is a bad code. Like you can see as per the definition, subtypes must be substitute for their base type. Means here you can see my subtype is not the substitute for my base class because it is throwing some exception. It is not a good practice for this kind of principle, for LSP principle. For this we can write like, I have to create a class interface. It is going to be send me the type of thing. If it is a bar type, then it should be implemented that bar type. Okay, then what I did, like I have another interface I have created called as flying bar. It is extending our bar, and inside flying bar I have created an abstract method called as fly, because flying bird can fly. That is a simple example. You can see here I have created two classes, one is sparrow and another is orchid. For the sparrow, they can fly. I can directly implement it my flying bird principle here. So that flying bird interface here. You can see by flying bird interface, I can implement that fly method here. How that sparrow fly. Then similarly for the orchid, they cannot fly. I don't want to implement those flying bird. Here I can directly implement my bird interface. Here that orchid can have own method, something like run faster, something like that. Okay, this is the good example for my LSP principle. Let me go to the fourth principle. Okay, it is nothing but interface segregation principle. As per the definition, you can see interface segregation definition as per the name. Okay, don't force a class to implement interface it does not use. Means here you can see some example for orchid. If I want to implement the flying bird, is used for orchid? See, orchid can fly. Okay, sorry, orchid cannot fly, but my flying bird interface having a abstract method called as fly. If I am going to use here my flying bird as a implementation in place of bird, then it is going to be a bad practice. Like why it is a bad practice that time? Because orchid is not going to use that particular fly method, but I am forcing orchid to throw a exception for a fly method. It is not going to be a good practice for this kind of principles. Okay, as per this interface segregation principle says, don't force a class to implement interfaces it does not use. Means I cannot, for this example, I cannot implement that flying bird here because I cannot force a class to implement something which that class does not use. Okay, for this also I've created some example. ISP bad example is like I created a interface called as multi-function functional devices, and it is containing three methods: print, scan and fax. Okay, I have one old printer. It is going to be implemented that multi-function device. Okay, you can see here for the old printer they can only print, they cannot scan or fax. Here what happened for the scan and fax, it is these are going to be throw some exception. It is not going to be a good kind of implementation code, because here you can see for old printer that is no require for the scan and fax. Why they are using that multifunctional devices? Other than this, what we can do, we can create, for the good code will be, we can create a printer interface which is going to only print. Similarly for scan and fax, these are going to their separate operation like scan and fax. We have to create a class as simple printer. Okay, just like our normal printer. There I am just only implemented the printer. It is going to be only print, not any scanner and fax operation it will be do. Second class, I am creating a multi-functionality printer or a multi-function printer. It is going to be implement all the three because they can print, scan and fax. It is going to be a good code for as per the ISP principle. And here you can also use similar kind of concepts in your projects or in your like you can just improve your code base like that, like this. You can just implementing these things. Okay, then let's go to the last principle, that is dependency in inversion principle. You can see dependency inversion principle says depend upon abstraction or depend on abstraction, not on concretion. Abstraction and concretion, this word is just like abstraction means a class a method should not have any implementation. It will be ended with a semicolon after the braces. Okay, similarly for conclusion, the definition is like you should have something, like it's not a nothing like a abstract, just like it should have some implementation there for that method, that is conclusion method. Okay, like as per the definition said, depend upon the abstraction, not on the conclusion. Means our logic should depend upon the abstraction, like we have to create a abstract class or a interface, we have to depend upon those unimplemented or non-implemented abstract methods, and we have to create class and those implement or extend those class or interface, and we have to concrete, we have to write the logic inside our class. Okay, this is called as for the dependency inversion principle. Let me go to the bad code. Bad code said like PayPal payment, I am using a class and it is having something like void make payment. Okay, and it is a concrete method, you can see here. Okay, for this, if I am going to use a payment processor, okay, I'm using a PayPal payment and I have to process those payment by using PayPal payment. What will be happen here? If something changes in our PayPal payment, then it is going to be also affect our payment processor, because we are writing those logic as per the payment processor, we are not writing the logic as per our convenience. Okay, that is going to be hamper for our code base. For this kind of thing, what we can do, we can directly create an interface called as payment service. It is having a pay method, that is a abstract method. Here you can see that is ended with a semicolon. We have to create a class as PayPal payment. PayPal payment is going to implement our payment service and having some multiple payment, like whatever the logic they can use. Why you are using this? Okay, first just understand why you are using dependency inversion principle. Okay, just think, if I want to implement some other logic, if I want to implement some other payment gateway, that time what I have to do, then I have to write another logic for that. Okay, rather than this, what I can do here, I have created an interface payment service having a pay method. I have created two different payment gateway, PayPal and Stripe, and I have in my payment processor, what I do, if I want to use Stripe processor, then I can directly create a object for a payment service with the help of Stripe payment gateway. Then I can use that, reuse that service, that object into my payment processor to process those payment. If I want to use a Stripe payment, I can directly create that new Stripe object for the payment services. That will going to be help me to, rather than depending upon the those conclusion, I can depend upon a abstraction that will going to be help in this kind of situation. Okay, this is the five principle for those like whatever the solid principles here. Okay, let me go to the next slide. It is going to be a summary kind of thing. Here you can see SRP, that single responsibility principle. One class should have one job. It is goal for maintainability. OCP is S10 without modifier. It is only for the flexibility. LSP is derived should behave like base. It is for reliability. ISP used for focus interface coupling. It is for do coupling. DIP depend on abstraction. It is for testability. Okay, this is the summary for our solid principle. Let me go to the next slide. That is the final thought. What we learn? Like solid helps build strong foundation for scalable softwares. Okay, if you are going to implement these things, if you are into a project, you can just go through code base. You can find out like similar kind of principle they are using, like solid principle should they are using, but you have to just find out where they are using this, where they are using SRP, or where they are using OCP, or where they are using LSP. Like this you can just search and just comment, comment was like which kind of principle they're using for a particular class. Okay, don't go for the code, just tell me this principle they are using. Okay, then think in term of responsibility, extension, behavior, focus, and abstraction. It is the like solid principle. Means it is going to be for terms of responsibility, extension, behavior, focus, and abstraction. It is going to be helpful like this kind of thing. And then like apply this principle gradually as you design about. Like I already tell, you can just apply this principle, or else you can just go through your code base and check where this kind of principle are using. If they are used this kind of principle, you can just comment. Okay, and this is like the solid principle this for this topic. Like you have to understand the object oriented designing. This is the part I have just include some few examples here. It's better to keep practicing and keep doing, then you can learn more. Okay, that is the one thing I can say. uh it's okay. And also you can watch my DSA playlist. I know it is not completed, but I'm trying to make some videos for there. uh this will be going to be help you all. Thank you all and have a nice day.